this. So reflection, we know that whenever the magnetic flux, that is we already done in the previous 2 lectures in this electromagnetic induction, what is that particular process. So whenever the magnetic flux passing through a coil changes, it generates electromotive force and current. Okay, the same question arises when we want to know what happens when the magnetic flux is passed through a solid coil. Will it also be able to induce EMF and current? So yes, it is going to be. Let's see that. So the real life connect in this particular subtopic is going to be braking mechanism in trains. I already tell you guys, told you guys in the previous lectures, like magnetic braking system in fast moving train. Magnetic braking system in bullet trains. You can see bullet trains means run very fast. Okay. Then the second application is this electromagnetic damping. What it is, we're going to see electricity meters at homes, inductance furnace, speedometer, rides in a measurement park, non-destructive testing, induction cooktops. Okay, so whatever the particular these examples are, you use in somehow, and we use them in somehow in day-to-day life, like electricity meters, whatever the meter in your home that is working on this particular EMI AC. Electromagnetic damping, it is a process in which a large amount of unnecessary current is going to be damped somewhere. Okay, like you are, we as a human damping our waste product. Inductance furnace, there is a furnace with which we are going to use or the heating effect of current. By the current, this particular current is AC, alternating current or induced current. Speedometer, everyone knows here. Speedometer is a example in which is going to give you the speed of a automobile. Okay, this is your speedometer look like. There is a in this kind of, okay, and then this. So that is the range of your speedometer from 0. So then 25, then 50, then 75, then 100, then 150 also. So in this way, speedometer works. Rides in an amusement park. The students who went amusement park in their life till now, at any particular point, so they know in amusement park what happens. The height of that particular you can say swing is going to be very far away. So obviously then due to this magnetic effect, AC alternating current is going to be converted into again magnetic effect, and due to magnetic effect we are going to convert that magnetic energy into mechanical energy. So with that particular energy system, there is a high rise in the swinging system in amusement park. Non-destructive destructive testing, induction cooktops, these are the few basics things which we are going to see in a real life example. Inductance. Now what the particular thing is this? So inductance is the tendency of an electrical conductor to oppose a change in the electric current flowing through it. L is used to represent the inductance, and Henry is the SI unit of inductance. As simple as that. Simply process you're going to understand in this way. Suppose there is a wire. Okay. And we know this, the opposing property of flow of electron, which is basically current. Okay, obviously this flow of current is going to be in this way. Suppose if for this particular wire beta, if the current is going in this direction, right? So automatically it is proven, and we know current is basically the flow of opposite to the flow of electron. So electrons are basically flow in this direction. Is this understood to each and everyone? So the oppose of flow in any particular conductor is known as resistance. I think that much is clear, everyone. Okay. Resistance is what? Oppose of flow of any particular moving charge particle or oppose a flow of current basically. This one is your current. This one is my current. And this one is my charge particle. Okay, charge particle. So this thing is known as resistance. In a same way, when we have this particular coil, okay, when we have this particular coil, or this coil is attached with a galvanometer, this coil is attached with a galvanometer. So what happens? If I change the magnetic flux, or if I try to move my magnet towards this, so there is a current is going to be, okay, and the current is going to be in this way, as simple as that. So the oppose of flow of this particular magnetic flux or oppose of flow of change in magnetic flux is known as produced by a electrical conductor. Whenever there is a thing, whenever there is a magnetic flux is passing through this, that particular oppose is known as inductor or inductance. Is this clear, everyone? Is this clear first of all, or not? Tell me, everyone, yes or no? Is this clear, everyone? So in a same way as this particular subtopic topic is invented by the scientist named as a Henry, so inductance and the SI unit of inductance is defined as a Henry, where 1 Henry is defined as the amount of inductance. It is defined as the amount of inductance required to produce an EMF of 1 volt. In conductor, when the current change in the conductor is at the rate of, it is not, as you can see clearly, it is not current simply, it is at the rate of 1 ampere per second. So what is happening here, as we know, in a simple way, induced current I induced is 1 by R EMF, or you can say electromotive force, this, where this electromotive force is itself is d phi by dt. Clear? Is this clear, everyone? Clear? So in this way, the oppose of flow of this particular, you can say 1 Henry is defined as the amount of inductance required to produce an EMF of 1 volt. Clear? In a conductor, when the current change in the conductor is at rate of 1 ampere per second. So now if I am saying di by dt equals to L E. So this L is known as a inductance or inductor. This inductance is defined as this, in this way, when my current is changing 1 ampere per second, or it is defined as a Henry, 1 Henry. 1 Henry is defined as the amount of inductance required to produce 1 EMF of volt. An EMF of 1 volt in a conductor means when this L is going to be 1 upon di by dt, okay, 1 upon di by dt, E equals to, as we know, E equals to N d phi by dt. So in a simple way, E equals to minus L di by dt, right? Like we have, wait, this is reverse I'm writing. Yeah, now it is correct. Like in a simple sense, then L 1 upon di by dt. Like in a simple sense, we know Ohm's law, which is in general V that is the resistance. So here resistance, or in AC effect, induced EMF when it is going to be 1. So or di by dt, change in current is going to be 1 ampere per second. So that is going to be opposed, and that oppose is known as your inductance. So 1 upon di upon dt into, that is your inductance. Is this clear, everyone? And that is 1 Henry inductance. Is this clear, everyone? And what should I do with your this negative screen, or you can say Black screen. Tell me, beta. I mean, I'm going to mail. Believe me on this. See, I'm literally done with you guys. Literally means literally. Neither you respond or neither you, I mean, tell me anything, whatever I am asking. Neither you understand, I think so. You just sitting like numb here. Numb, I mean, like dead people. And believe me in this, if I'm saying this hard word and harsh words to you. Because sitting here like this, it makes me more irritated. Okay. So everyone's screen is going to be stuck. Everyone's this what is this? Internet and connectivity is going to be slow. Everyone is facing some issue. Is there any a single particular day is going to be in your life when you're going to say the correct things? At least. Okay. Okay. So in this way, like we have a resistance to oppose the flow of current. In the same way, whenever the EMF or induced EMF is going to be generated, so to change the amount of current, why amount of current is going to be changed? Because as we know, if this particular magnet is now here, so I explain in a very great detail manner the north pole, south pole of this coil is going to be changed. So the current needs to change as per unit time because magnetic flux is changing as per unit time. So inductance 1 Henry is defined as the amount of inductance required to produce an EMF of 1 volt in a conductor when the current change in a conductor is at the rate of 1 ampere per second. I hope and I believe it is clear with your all. Okay. Factors affecting the inductance of any particular coil: the number of wire turns, number of wire turns in the coil, coil area, coil material, coil length. Okay. Derivation of inductance. Now we are going to define the inductance. What is an inductance? So take a look at a DC core source that has a switch turned on. When the switch is turned on, the current flows from 0 to a specific value, causing a change in the flow rate. The flux change in is measured of time flow. As we know, flux change is d phi by dt. Using Faraday's law of electromagnetic induction, E equals to n d phi by dt. Or above equation using Lenz's law, E equals to minus n d phi by dt. We already done this thing in a great detail. Go and check it out if you don't understand right now. For computing the value of inductance, the previous equation is adjusted. E equals to minus n d phi by dt or E equals to minus L di by dt. Okay, this is my Faraday's law. Faraday's law, and this is the induction, or you can say inductance. This is inductance. So equating equation 1 or 2, n equals to d phi equals to L di. Okay, so if for small change, now n, as you can say, n d phi, and that is not correctly written here, the negative, this sign is not going to be, yeah, n d phi, comparing equation 1 and 2 from right hand side and left hand side both. Okay, so EMF, n d phi and L di and d by 1 by dt is removed. So comparing equation 1 and 2, what we get from the right hand side, n d phi equals to L di, means the change, the product of number of turns into the change in flux is equal to the inductance in change in current. And then we're going to find it out N5 for change very small. So you can say for flux or current for d phi equals to phi and di equals to I. What does this mean? If change is negligible means zero. What is the meaning? You can say um, instead of saying that di means I, like I2 is going to be 0, because you can say I1 is I and I2 is 0. So di change in I1 minus I2 is I1. That is the meaning of saying that. Okay. So basically for large flux and for large current, when change is going to be the simple, or initially the flux is 0 and initially the current is 0, so we can take d phi equals to phi and di equals to I. Simply n phi equals to li. Therefore li equals to n phi, phi equals to ba, because we know this, that is magnetic flux, b dot a or simply ba. Okay, this is my magnetic flux, magnetic field into area. So here B denotes the flux density and A denotes the coil area. We can write this one also B by A, or you can say if a okay B upon Ni, where B denotes flux density. Okay, flux density is basically going to be magnetic field per unit volume. So H is your magnetic field, HL equals to Ni. There is one equation, Li equals to N phi equals to NBA. So you can find your inductance from here also, and you can find your inductance from here also. Is this clear, everyone? Because we know where H denotes magnetic flux, magnetizing force from the previous chapter. We know this relation, B equals to mu naught H. So Li equals to NBA, L equals to NBA upon I, or you can say N square, it is a square, BA upon Ni, because multiplying and divided by I. So N square BA upon HL, and I you can put from this equation HL, and then you get this. Simply L equals to mu naught N square pi r square, A is basically pi r square and L. Okay, so there are 2-3 different formulas. Whatever particular formula you can like, you can get it. Is this clear, everyone? Is this clear? If you have any question, query, so you can ask me. Obviously, you are going to ask me. You are not going to ask, but still, if you have, so you can ask. Should I move ahead? Tell me. I think other than Yajra, 7 to 8 people are there also, 6 at least. So everyone means I'm not asking only from Yajira, right? Clear na, everyone? Good. Okay, so now types of inductance, as we already covered this particular thing in the last class. There are 2 types of inductance, self-inductance, mutual inductance. Self-inductance is going to be the subject whenever there is we have a single coil, and whenever there is a single coil, so the due to change in flux in a single coil, there is a change in current is going to be, and due to this change in current or due to induced current, there is a flux going to be generated, or you can say there is a inductance going to be generated. So there is a self-inductance, mutual inductance. There are 2 types of inductance. Let's see, let's look it out, whatever these are. So with a self-inductance, as we know, there is a coil. In this particular coil, there is a magnetic field passing through. So obviously, whenever there is a magnetic field passing through or magnetic flux is going to be changed. So in this particular coil, the induced EMF is going to be generated. And this induced EMF is creating your current with the help of this rheostat. So this current is going to be changing also, because your EMF is going to be changing as the EMF or as the magnetic flux is passing through. So when there is a change in a current or a magnetic flux, because change in current can be appears because of change in magnetic flux, and magnetic flux is going to change. That is one simple thing to understand. So when there is a change in the current or a magnetic flux of the coil, an EMF or an electromotive force is induced. Okay, this phenomenon is termed as self-inductance. Simple. Okay, so EMF is going to be induced because of this particular process, and this phenomenon is termed as self-inductance. Okay, when the current starts flowing, through the coil at any instant, it is found that the magnetic flux becomes directly proportional to the current passing through the circuit. So this relationship gives me phi equals to Li. Understand this thing again, phi equals to Li, and this L is self-inductance. When a current or magnetic field change, like we know, if I produce a current in a coil, so it becomes a magnet, and according to the, because if we taking simple solenoid, so B equals to mu naught Ni. Okay, so if I change this I can change my magnetic flux. So either I can change magnetic flux, either I can change current. On both of the ground, I can produce EMF. Clear? Because EMF is electromotive force, is nothing but d phi by dt, where phi is nothing but magnetic field into area. Magnetic field into area. So that is the thing. So I can play accordingly or as my requirement. Either I can change B, either I can change I. As simple as that. The moment I change I, electric current, the simultaneously I can see the change in magnetic field. The moment I see the change in magnetic field, I can see the change in flux. At the moment I can see the change in flux, I can see the change in EMF. Everything is correlated here. Okay. So self-inductance, when the current starts flowing through the coil at any instant, it is found that the magnetic flux becomes directly proportional to the current. So phi directly proportional to B, because area going to be kept fixed for this particular coil. Area we are not going to change. And phi, because mu naught is a constant, N is a constant. N is number of turns per unit length. So in this way, your phi directly proportional to Li. Because phi directly proportional to B, the moment I fix this constant. Because once you made a coil of any particular area, so simultaneously we not change the area. In a same sense, the number of turns is going to be never ever change once we make a N fix. Is this clear now, everyone? Is this clear till now? So this relationship gives us, this all the things gives us this terminology, or this. Okay, phi equals to Li, and here L is self-inductance, nothing more than that. Here L is self-inductance. So it is self-inductance L equals to N phi by I, because we have a N number of turns also. So coefficient of self-inductance, okay, coefficient of self-inductance L equals to N phi by I. If I equals to 1 ampere, N equals to 1, then L equals to phi when the current in a coil is 1 ampere. The coefficient of self-inductance is equal to the flux associated with a coil. So using Faraday's second law, induced EMF E equals to minus N d phi by dt, which gives me E equals to minus L di by dt. Means now this is clear. If you are still have a question and no one asks me there, why should I write this thing without explaining? from where I get this relation? Obviously, if the left hand side is equal, so from where the right hand side is equal. So from here, the right hand side I can make the equal. Is this clear now? At least, I mean, to write this particular thing, there is a relation L equals to n phi by I. So with this, I can do that. Means L equals to n phi by I. So n is constant d phi by dt. L is constant di by dt. If I'm changing both sides with respect to time. So that is why instead of n d phi by dt, I can write L di by dt in place of n d phi by dt. And both the things gives me induced EMF. Okay, units and dimension formula, that is important also. Sometimes they ask directly. Focus here, units and dimensional formula of L. Its SI unit is Weber per ampere or Tesla into meter square per ampere. Okay, or Newton into meter per ampere square, Coulomb into volt per meter square, volt into second per ampere, or ohm into second also. So there are so many units of this. Okay, because in different criteria, in different formulation, we can make this. But practical unit of Henry, but practical unit of inductance is Henry. Its dimensional formula is L, which is mL square T minus square a to the power with this Tesla into meter square divided by ampere. So from this you can get this relation. Tesla is basically the magnetic force. So thereby mL T minus 2 divided by AT square. Okay. And we can find it down. Is this clear, everyone? Okay. So let cross-sectional area of a solenoid be A, current flowing through it be capital I, length of a solenoid be L. So phi equals to BAN. Okay. B equals to mu naught Ni upon L into AN. So that gives me mu naught N square A by small n, that is I. So phi, which is Li, gives me L equals to mu naught N square A upon L. Like this is for solenoid, self-inductance for solenoid and the important case. Okay, important one, why so and how so. As we know, magnetic field for any particular solenoid. Okay, I'm going to write as mu naught N I. Clear? And Ni, where this N is nothing but N capital L. So I can write B as equals to mu naught capital N upon capital L into I. Now I can write this thing also. Phi equals to B NBA. I remember in this way NBA. So N, putting the value of B, which is mu naught N upon capital L into I into A. Okay. So just putting down A here. So then I can get phi directly this one. Okay. Phi equals to mu naught N square A I upon L or capital L, because I picked capital L since beginning. Okay, and from this there is one relation, and I also know there is another relation. What relation? Phi equals to Li. So now this is my equation number 1. Now this is my equation number 2. Okay, here L is inductance, and okay, that's why I keep it small l, small l, and small l. So but a capital L is you can say inductance. Clear? Here I can also put small l, small l. So from equating one equation and two equations, which is L inductance L is nothing but mu naught N square A upon L. And you can see there is no I, no B, and that is constant, independent of magnetic field, independent of current. directly proportional to the you can say coil dimension. Everything is related to dimension, like N is unitless, A is dependent on the coil area, L is dependent on the coil length, mu naught is permittivity, N is constant. Is this clear? And obviously which particular material you are going to take, that is also going to take more efficiently. So if no iron or similar metal is nearby, then the value of self-inductance depends only on the geometrical factors. Clear? Why this particular line, if no iron or similar material is nearby? Means if they are going to be, so they give the effect on magnetic field, because magnetic field then attract themselves. So the moment magnetic field attract themselves, this phi going to be not directly Li. This phi is something else, because magnetic field is going to be decreases. Okay. So for this particular terminology, L is dependent on the geometrical factors. So this particular statement is L, which is self-inductance, generally depends on geometrical factors only. Geometrical factors. Is this clear, everyone? Geometrical factor means length, cross-sectional area, and number of turns. Mu naught is permittivity. Is this clear? Is this clear, everyone? Okay. Now, in the same sense, we can find out. This is important one also. Now, in the same sense, we can find out in self-inductance of a plane coil. So let current I flowing in a plane coil of radius r, n number of turns in a coil, magnetic field at the center of the coil, mu naught Ni by 2r. Now what is the meaning of a coil here? 1, 2, okay, the same thing. I need to draw this, 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 this. Okay, I mean I do a little bit more, but the main thing is this coil have a constant radius r. Okay, B magnetic field. So that is your magnetic field formula, mu naught Ni by r. I flowing the current. Okay, B equals to mu naught I upon 2r. Magnetic flux turn, magnetic flux per turn of a coil, BA. Cross-sectional area of the coil, A pi r square. Clear? Total magnetic flux linked with n turns, phi equals to simply this BA, and you can say B is this, mu naught N square, NBA in general, that is the same thing. Okay. So mu naught N square I upon 2R into A. Putting the value of A, which is pi r square. So phi is this. Okay. Phi is mu naught N square R upon 2. This is your magnetic flux for coil. Okay. This is your magnetic flux or plane coil. Solenoid, this is not solenoid, plane coil, simple one. Okay, simple coil but having n numbers, plane coil. So again, but phi equals to Li. So for that reason, this is my, L. Okay, mu naught pi N square R by 2, and that is important. Directly you can use. Is this clear, everyone? I don't think so any particular thing is bothering you in this. Okay, is this clear, everyone? No doubt. Good. Okay, so now self-inductance. This is very, very important. Using this particular single thing, you are going to get so many, you can say, numericals. The magnetic potential energy of inductor. Now this is everything for what we are doing this mesh thing. See, the conversion of magnetic energy to electrical energy, then electrical energy to motional energy, then motional energy to motional energy is basically mechanical energy. Okay, now here we have a three things: mechanical, I am going to write MECH, then electrical, okay, and then magnetic. There is a circus, or there is a cycle is going in between this, and this, and that is everywhere. Any particular electrical instrument which is going to convert electrical energy into mechanical energy, it is not going to do the direct. Either your electricity is going to create a heating effect, or either it is going to create a magnetic effect. So with the magnetic effect, you get the rotating effect, or generally with the rotating effect, we convert mechanical energy. Simple grinder or juicer mixer. Okay. So have you tried to broken that, or try to open that juicer mixer? What is going on inside? There is a coil in this way. Okay. Due to this coil, a magnetic field create, and then in between there is a you can say a shaft look like this. It is situated, and then here we have a blades in a grinder. So due to this magnetic field you can say generation, this is going to rotate. The more electricity is going to be, the more torsional effect is going to be, and due to the more torsional effect, the more it is going to rotate, and the more it is going to rotate, the more blinder, or you can say your juicer mixer is going to do the grinder thing. Grind this particular dry fruits or vegetables, onion, chili, tomato. Okay, so in this way the cycle is going to be like this, from this to this, and then again from this to this, and then this. Like you put a magnet, we are going to do this in this particular session only. We are going to put or create a magnetic field, then we provide the mechanical energy. What is the mechanical energy? With the AC generator, we are going to rotate the coil. The moment we rotate the coil, there is a production of induced EMF, or electrical energy, or electricity in general. So to reach any particular type of energy, okay, these are the, you can say, different criteria and types of energy. You need to follow at least two. You cannot do that directly, like electrical energy is going to convert directly into mechanical. It's okay sometimes, but in general principle, in maximum number of cases, the two-step way is going to be done. Clear? Like you can think of electric motor, fan, anything. Anything means most of the thing. I'm not saying everything, but most of the thing. Like your electric motor, like your AC generator, like your juicer mixer, or you can say a fan. Whenever there is a rotatory effect, or there is a mechanical energy you provide, you get, or with the help of mechanical energy, you can get this thing, electrical energy. Then also, okay, like electric motor, AC generator, turbine, everywhere the mechanical energy convert first magnetic energy, then magnetic energy convert that thing into the electrical energy with the electric you can say this AC generator. Is this clear, everyone? Good. So the magnetic potential energy of an inductor, in order to create a continuous current, in the circuit, the source EMF must work against the coil's self-inductance. Clear enough? And energy expended for this work is stored in the coil's magnetic field. Clear enough? Which is referred to as a magnetic energy, or you can say magnetic potential energy, and that is very easy. Half Li into I. You can say 1 by 2 Li square. Okay. As we maybe you remember, maybe you not, in capacitance system we have a potential energy to store the charge, and that is QV CV square, because Q equals to C. You remember now? This is clear. So in a same sense we have this. Now if I put the value of Li, Li is N phi, so I can get this one also. Okay, so this is important. Nothing more than that. There is a theoretical aspect. I mean, on theoretical aspect, nothing more than that I can explain. Nothing it is necessary or even. Simply to complete the circuit, to make it flow, induce current, there is a energy required, and that particular energy is magnetical, or you can say magnetic potential energy of an inductor. That is the energy of an inductor. Okay, in order to create the continuous current in the circuit, because if it is not going to push by this energy or push by this magnetic potential energy, so your current is going to be stopped, because this L inductance or this coil is you can say oppose the flow of magnetic flux, and if it is opposing the flow of magnetic flux, so one time is coming, then your all the magnetic flux is opposed by the coil itself, and there is no induced current. But it is not happening in general. So if it is not happening in general, then there is a side subsidiary thing, which is a magnetic potential energy of an inductor, which is suppose the flow of a magnetic flux, which is suppose the continuous flow of a induced current. Is this clear, everyone? Good. Now, self-inductance, the various formula for self-inductance. There is no need to describe that. But important one, like circular coil, L equals to this. Solenoid we describe, even toroid we have. Square coil this, okay. And then there is a mutual inductance. So in a same manner, like a self-inductance is going to be only and only for simple one coil in itself, but in response of that, mutual inductance is a particular kind of inductance that is going to be generated by one of the, I mean, it is going to be generated in another coil. Like if your this induced current and change in magnetic flux is passing through one current, so the flux is going to be mutually generated by another. So that is your mutual inductance, first of all. So what is a mutual inductance? Like C, first of all, consider two coils, okay, this one coil and this two coils. Right. P coil is a primary coil and S coil is a secondary coil. A battery and a key are connected to the P coil. As you can see, instead of L1, L2, you can write PN, Q. This is your P, this one is your Q. Okay, a battery and a key is connected to the P. As we can see, battery and key is connected to the P. Okay, fair enough. Whereas a galvanometer is connected to the S coil. Okay. When there is a change in the current or magnetic flux linked with the two coils, an opposing electromotive force is produced across each coil, and the phenomenon is termed as mutual inductance. If in any particular coil I can change the current, so in a simultaneous way, the moment I change the current, the moment I can change the induced magnetic field, or you can say because of changing current, I can change the magnetic field, and the moment the magnetic field is changed, flux is changed. So if I change the current here, I change. So simultaneously on this particular coil, magnetic field change. Due to this magnetic field change, beta, there is a change in induced EMF, or there is an induced EMF is going to be generated here, and this EMF is also changed, right? Then EMF is going to be changed, and the moment EMF is going to be changed, your inductance is going to be produced, and that inductance is mutual. Why mutual? Because of it is not, I mean, this particular inductance is not occurring or happening because of its own coil. It's occurring, it's happening because of another's coil. Is this clear, everyone? So that is mutual inductance. The phenomenon is given by the relation F equals to Mi, very important, where M is termed as the mutual inductance of a two coils, or the coefficient of mutual inductance of the two coils. Now, the rate of change of magnetic flux in the coil is given as E equals to minus d phi by dt. In the same way, M di by dt equals to E equals to minus M di by dt. Then mutual inductance, everything remains same. Like mutual inductance, M is mutual inductance coefficient according to Faraday's law, this, that, and everything, M di by dt. If di by dt 1 ampere per second, then E equals to M. Units and dimensional formula of M, it is SI unit, Weber per M meter, and the practical unit is Henry. So it is same. Now the formula for M, that is important. Okay. So two concentric coplanar circular coils having a mutual inductance mu, you can say pi mu naught n1 n2 upon r square into 2r. Two solenoids have mu naught n1 n2 upon a into l, and two concentric coplanar circular coils have this. See, I can derive the formulas also, but the derivation is not required. Why so? Because it is omitted in your CBSE. So directly, okay, one thing I can give you, why n1 n2 is going to be, see, we understood phi for a coplanar coil, or for a coil, simple, mu naught n r square upon 2r. Okay, or wait, for a coil, what is this particular thing? For a coil, L is going to be, for a coil, plain coil, mu naught n square by 2, right? R square by 2 for a simple coil. This is the formula. L, or you can say phi equals to Li, simple, for, and L equals to mu naught n square, and what is the formula? N square mu naught pi n square r upon 2, mu naught pi r square on 2. Is this clear? Now, this is just because of this single one coil. Okay. Now, if I am saying we have a two coil, instead of this, I can make another coil also. And this, the radius is r, the radius is r, and the distance between them is 2, capital R. Okay. Now, if it is have n1 number, if it is have n2 number, so in this particular n2, the mutual inductance M, mu naught n1 n2, r square, because area thing, and instead of 2, simply divided by 2L, because it behaves as a solenoid. So now instead of L, I can put directly 2R, because the distance is R, capital radius R. Is this clear, everyone? Is this clear, beta, everyone? Okay. And if specifically you want this particular derivation, so we can do that in DRS. Okay. So for two solenoids, that is that. I mean, this is, so this is your important formulas, and based on this formulas, you can get the questions. Now, combination of inductance, like series combination of inductance, two coils are connected in series, coils are lying close together, so M is going to be 0. If, then L is directly in this way. If they are not, so that is their relation. When a current, when current in the both of the, when the current is flowing in the same direction in both, so L is L1 plus M plus L2 plus M. And when the, that is going to be the same, this particular formula. And when current flows in two coils are mutually in opposite direction. So then N1 plus L2 minus 2. So these are the some important formulas again. Okay. Two coils are connected in series. Then series combination of inductance. Parallel combination, like a similar thing, parallel combination 1 by L equals to 1 by L1 plus 1 by L2, or L is this. If M is 0, if M is not 0, then 1 by L equals to 1 by L1 plus M plus 1 by L2 plus M, and do the calculation. And that is your difference between self and mutual inductance, the main thing. The coil self-inductance is a property of the coil. The characteristics of a pair of a coils is mutual inductance. When the main current in the coil declines, the induced current resists, and they decay, and the decay of current in the coil. When the main current in the coil declines, the induced current created in nearby the decay of the current in the coil. Okay. When the coil's primary current grows, the induced current opposes the expansion of a current in the coil. Means when in any particular coil there is a current growth is going to be, you can say when coil's primary current grow, the current is going to starts growing. So induced current starts opposing, and the expansion of current in the coil is going to be. When the coil's primary current grows, the induced current created in the adjoining coil opposes the coil's current development. Means then in the adjoining coil, the current is going to be decreases, or it is going to oppose. Okay. Now there is a full-fledged eddy current. Okay, I added down this thing. So what is eddy current? Let's see this. Induced electromotive force is produced in the coil. I mean, eddy current is just a current which is going to be flow in the opposite, as simple as that. Okay, so let's see this, what it is in general. Induced electromagnetic force is produced in the coil when there is a change in the magnetic flux linked with the coil. Eddy currents are named so because the current looks like eddies, or you can say whirlpool. When a conductor is placed in a changing magnetic field, the induced current in the conductor is termed eddy current. Means there is a production of induced EMF whenever there is a change in magnetic field. Magnetic field is going to be, but if the change in when a conductor is placed in a changing magnetic field, but if the magnetic field is changed, going to be the induced current in the conductor is termed as eddy current. Means whenever we see this particular EMI effect, so induced current in any particular conductor is termed as a eddy current. Eddy current are loops of electrical current induced within the conductors by a changing magnetic field in the conductor. According to Faraday's law of induction, eddy current flows in closed loops within the conductors in plane perpendicular to the magnetic field, and that is what this thing. Eddy current is going to be in whirlpool. Whirlpool is what? Not your Whirlpool is a brand of, you can say, a washing machine or fridge, but it is not in general. This field, and it is going to be decreases. Okay, so this is your electromagnetic field. If it is a coil, in this particular coil, the AC current is going to be generated. So, or passing through. So this is what your eddy currents look like in this way. Okay, as you can see, it is going to be increases more and more and more and more. So that is the look-alike thing of eddy current. Now it is your first question. Do that, try that, and I am going to take a break. That is very easy. Consider a 500-ton solenoid coiled on an iron core with a relative permeability of this. The solenoid length is 40 centimeter and its radius is 3 centimeter. The current change from 0 to 3 ampere. Calculate the average induced EMF for this change in current at a 0.4 second arrival interval. Okay. So very easy question. Try that. If you are not able to, I am going to explain it. Okay. N is given, mu r is given, length is given, radius is given, di is given, dt is given. You just need to put the formula. And formula I am not going to tell you guys. Okay. Is this clear, everyone? Okay. So there is a break, and you in between the break you can do that. Hello, hello, hello. Am I audible? Exactly the correct answer you are going to get. I mean, yes, it is almost correct. Let's solve it out. 13.27. It is quite near about. So consider a 50-100 ton solenoid on an iron core with a relative permeability. This or solenoid of length 40 centimeter, radius is this, 13 point something. Okay, so that is near about. That's why I'm saying. See, n is this mu r. That is this thing is it. Mu r is 800, and mu we going to put mu r into mu naught if I'm not. Whenever mu r is given. So length is 40 centimeter, change in current that is di 3 ampere, change in time dt is 4 seconds, and putting everything self inductance L equals to mu n square al. Why should I put mu here? Because whenever you have mu r, so that is relative, and you need to put mu then mu naught into mu r. Is this clear, everyone? So 13.275 or 13.375. Okay, beta. It is 13.275, not 375. Putting the values n square mu naught mu r n square pi r square by l, everything is given 4 into 3.4, that is 4 pi into 10 to the power minus 7, and 800 500 square, then pi 3.14, then r square, radius 3 into 10 to the power minus 2, which is 3 centimeter, and then 0.4. Okay, and L. So the directly L equals to this. First we get L, and then we get L equals to di by dt. Is this clear, everyone? That one is easy. Clear now, everyone? Okay. The next thing is, again the three coils are wired together in a series. Each coil has an inductance of this, respectively the coil inductance. See, whenever the coils are in series, so the thing is going to be directly, simply. Like the series parallel combination, okay, I can give you a hint. or a picturization here. If this particular one coil, okay, is connected to this particular another coil, and this connected to another coil. So in a same sense, if it is L1, L2, L3, so simply your L total, I mean inductance total or net, is going to be L1 plus L2 plus L3 and dot 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 if I multiply dot 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 here. Okay, and if it is in reverse way, like there is a circuit L1, L2, L3, okay, so then same thing but in a reverse way. L1, L2, L3. So here L net is going to be 1 by L net total, 1 upon L1 plus 1 upon L2 plus 1 upon L3 plus and so and so. Is this clear, everyone? So using this particular formula, that is very easy. Well, no need to discuss. The inductance of a coil is 6 Henry and the supply frequency is this. What is the reactance? Okay, this one is nice. Tell me anyone if they know so. Reactance. Reactance is omega L. I don't give you direct formula. Hint. Reactance. There are two types of reactance, one because of inductor, one because of capacitor. We are going to discuss in the next. Omega L. And one reactance due to capacitor XC, 1 upon omega C. Okay. So this reactance because of inductance. And this is because of capacitor. Capacitor. Tell me beta anyone. Reactance. I think now you can give me everything now you have in your hand to find reactance. Tell me. Tell me students, what is the reactance and capacitance? Oh, sorry. Reactance for inductance, reactance for capacitance. So reactance for inductance, I want to know here. You are, preparing for JEE, and if still given this formula you are not able to calculate, now you need to do a literally very, very hard work. Believe me on this. If you are not know how to get omega with F, 420. Beta 420, how you calculate 420? First of all, tell me. Self-inductance. What are you saying? Sir, for inductance. I am not inductance. Reactance, I am. Inductance of a coil is given, na? I give you the formula of a reactance. Still you are on that particular note of this. Arey beta, ऐसे कैसे चलेगा? Sankal sir is asking, are you coming upstairs? No, no. Tell him to come downstairs after the class. Okay, I'll call Sankal sir within a while. After. Arey beta. See, this is your answer. I don't know what you are doing. Omega is 2 pi f. Angular frequency. Frequency is given. Angular frequency you need to calculate, and even you don't need to calculate. You just need to put the formulas. Omega. If you don't understand what this particular symbol is, this, why don't you ask? Tell me. Do you think in this way you clear exam? I mean, for you guys, we are doing that much hard work. Sometimes you makes us feel ashamed. Believe me in this. I'm not saying because of this particular question only, but I'm saying because of your continuous behavior. And believe me, if I'm going to get your PTM not this time, beta, your parents start beating you the moment your PTM going to be finished. Believe me on this. I'm going to be very harsh with them then. The thing is, you are make me feel you are not interested to listen. Okay, tell me how many of you genuinely uh, are preparing or genuinely want to clear JEE, and how many of you are doing for the sake of your parents. If I get the appropriate amount of percentage, at least that makes me more clear. I'm not going to bother about you then after this. Tell me. If everyone here is sitting for genuinely preparing, then why don't you even ask and tell me this? If you are not understanding the symbol, it's okay too. Then ask, sir, what this thing? This thing is clear. And how many times I have to repeat this thing? You have to start the revision of class 11th also. And that is angular frequency, very basic thing, 2 pi f. Simple. I know I don't tease this, but when I give you this relation, and I want, and I expect being a JEE student from you guys, you can do that after giving this, and I want, and I'm saying repeatedly, reactance from inductance, reactance for inductance. Still you are sitting like numb. This thing is given frequency. See, okay, it is given. Henry is given, L is given. I don't know what for you are waiting then. Okay, it's okay then. This is your reactance for inductance. XL sometimes write or directly X you can write. Okay, the next topic is very important. Conversion of energy. I give you a brief intro, a brief hint already. Like whenever there are three types of energy: mechanical energy, electrical energy, and magnetic energy. I write it down this thing again for the better clarification. That is a mechanical energy. Okay. One energy is electrical energy due to electricity only. Electrical energy. Even electrical energy can be converted or subdivided into two things, which is magnetic or magnetic effect or heating effect. But still, due to electricity, whatever the energy we get. Okay, and then we have a magnetic energy. So these three kinds of energy interchangeable in between to each other. Okay, and the arrow can be reversed also. It is not necessary. We learn this thing, arrow can be reversed. Is this clear now, everyone? Like in this, we are reversing the arrows. In the previous chapter, moving charges and magnetism, what we learn, whenever there is a charge starts flowing, so that particular flow of charge creates a magnetic field. Now we are reverse this thing. If there is a magnetic field flow, if there is a flow of magnetic field starts happening in any particular conductor, so we can get a current, which is known as induced current. So this opposition, or you can say this flow, is going to be in any case. It's not necessary like electric energy can never ever convert into mechanical energy, or mechanical energy can never ever convert into electrical energy. They are both convertible. Clear, everyone? Okay. So a generator, everyone know this. This is a AC generator basically. First thing. So a generator is used to generate the electricity during the load shedding and power cut. It is a device that is used to convert mechanical energy into electrical energy. Clear? But how so? The process is going to be in this way. It is not convert directly. I mean, the process is not follow this, but mechanical energy going to convert electrical energy only and only in the presence of magnetic field. If you are not provide the magnetic field, if you are not providing the magnetic energy, so that is not going to fulfill the criteria. How so, why so, we are going to discuss in this lecture. So Faraday's law, everyone know this. Faraday's established two laws that govern electromagnetic induction. These are their names. When the when the amount of magnetic flux linked into a circuit changes, an EMF is formed. The induced EMF persists as long as the magnetic flux varies. So this is your first law. Okay, first law states that induced EMF is minus d phi by dt. Or for n d phi by dt. If we have n number of turns in a coil, simple. Okay. In a circuit, the amplitude of induced EMF is directly proportional to the rate of change of magnetic flux coupled with the circuit and number also. First of all, this EMF is directly proportional to d phi by dt. This negative signs is given by the Lenz law. We understood this thing, and that is why it is written in the recall, because we already done this thing. Okay, is this clear, everyone? Till now everything's fair enough. We already done this thing. Good. Now electric generator. The definition point, kind of thing. An electric generator. A generator is a mechanical device that converts mechanical energy into electrical energy. Fair enough. The electricity generated at a various power plants is produced by the generators installed there. When a coil spins in a magnetic field or moves related to a magnet, it generates an electromotive force, EMF, or potential difference. And when we have a potential difference in any particular conductor, without a doubt, applying a resistor, we can get the using Ohm's law. If we have V in the form of EMF, okay. So with this Ohm's law thing, we can get this IR. But R here, it can be two type. It can be XL, the reactance due to this inductance, and that can be directly R also. RH is rheostat. Rheostat is a changeable resistance. Is this clear? So everything is linked all together. Is this clear, everyone? Is this clear now? Good. So now, principle of electric generator. So the principle of electric generator is EMI, electromagnetic induction. As you can see, whenever there is a changing magnetic flux passing through any particular coil, so there is a production of principle of this thing is nothing but EMI, electromagnetic induction. Simple. I'm not going to write and repeat again and again what EMI is. Already done so many times. Types of electric generator. There are two types of electric generator: alternate AC, direct current also. AC generator produce the alternate current, while the DC generator produce direct current. Okay. Now AC generator. What it is? AC generator, a machine that transforms mechanical energy into electrical energy, is known as AC generator. Mechanical energy is supplied to the AC generator through the steam turbines, gas turbines, and combustion engines, alternating electrical power in the form of alternating voltage and current is the output. What is happening here in general, simply understand in this way. Every one of you went to the wedding, right? Any particular wedding. Outside a wedding hall or a banquet hall, there is or even in your school, there is a silent AC generator, which is run by the diesel, right? So what happening in that particular diesel engine or diesel alternating current generator, basically there is a engine fitted there, and the peon of a school or the, you can say, take care of a banquet hall is put the you can say diesel into that particular AC generator and then start the motor. The moment that particular motor is start, or basically diesel engine is start, so diesel engine is connected with a shaft. Okay, and this particular shaft is attached in that particular manner. Suppose there is a magnetic field, okay, or in between there a shaft is going to rotate in this way or in this way, and magnetic field is also there. So the moment my shaft is going to rotate throughout a magnetic coil in between the magnetic field, so there is a process of EMI. How so? Because magnetic flux is there or magnetic field is there and my coil starts rotating. Clear na? So due to this EMI process, due to this particular thing, EMI process in every particular power plant system, wherever I mean wherever or whenever the electricity or AC is going to be generated, this particular process is going to be happen, and due to this EMI process we get current, or basically alternating current, or basically induced current. Induced current is alternating current. How it is going to alternate this cycle, that is a you can say a magic, or that is a thing we need to see. Is this clear, everyone? Okay, simply this AC output is going to be continuous and it is going to change its shape, or you can say this frequency, positive to negative, because of this slip rings. This is your AC first of all. Okay, this is your I alternating, and that is your time period. So as you can see here, this is the ring and brush, and this is a rotator. So this rotator is going to rotate this particular coil continuously. Okay, and there is a this is, if you can say, state or field, stationary magnetic field. So due to this stationary magnetic field, as you can see, there is a coil also. So when this particular coil, this particular rotator is starts rotating, which having a coil also, which has this particular conductor also, or you can say wire also. So when this particular wires start rotating in a static magnetic field, in a situated constant magnetic field, there is an induction process is going to be. And why this cycle is going to reverse? Because one time this slip ring is attached with, you can say, this end, and one time is attached with this end. So one time this coil is rotate in this way, another time this coil starts rotating in this way, 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 opposite, and then together. I mean, in this way and then opposite, in this way and then opposite, opposite this way. Like how many of you play with this toy which having a monkey? I mean, we fulfill the keys in a monkey, and that monkey is going to start beating the drums, right? So what basically we do, we fill a you can say a key in that particular monkey. So until unless, okay, until unless that key is going to rotate, that monkey starts, I mean, continuously beating the drum or any particular musical instrument. The moment that particular key is comes to the zero position, that is stop. Again we do that 1 2 3, and you can say old watches are running on that particular manner. You have to fulfill that key to see the time even for a day, and if it is within a day or after a day, it is going to stop. So again we fill the key by seeing the actual time somewhere in the clock outside. Okay, so in the same way, the moment we start the diesel engine, this diesel engine is starting I mean filling the key, so it is rotating in this way, in this way, in this way, and that is why AC is having this particular positive negative positive negative positive negative cycle, because of the slip rings. Because slip ring is going to slip and make the contact continuously without giving the break. No matter how your rotator, no matter how your this particular coil is going to rotate. Is this clear, everyone? The process is simple. EMI, AC generator, works on the principle that whenever there is a change in a magnetic flux linked with the coil, a current is generated. And that is what? EMI. Is this clear, everyone? Okay. So moving ahead, in this way, as you can see, this there is a coil, there is a magnetic field, and these are the basically conductors, and these are the slip rings. As you can see, they make them connect all together. Even this coil is moving in this way, which is a clockwise, or even this coil is start moving in this way, which is a anti-clockwise. Clear, everyone? And why it starts moving anti-clockwise also? Because of Lenz's law, because of induced current opposes. Okay. So according to the Faraday's law of electromagnetic induction, EMF will be induced across the coil. Fair enough. The coil is start rotated continuously between the magnet, and current is produced across the terminals. So due to this rotation, obviously the rotation is going to be fixed one time, and the moment it starts rotating, so because of rotation, there is a current is going to generate in this way. Okay, according to the rotation. If you pick the, you can say, if you pick the clockwise rotation, so the current is going in the opposite flow. Okay, this, why should I pick this particular direction? Because your this coil is start rotating in this way. Okay, for this way it is in this direction, opposite, because the coil is try to move in this way, but the current try to move this in this way. The same thing is happening here. Okay, moving ahead, working of AC generator. Consider a rotating coil, consider a rotating rectangular coil having N turns. The magnetic field produced by the magnets around the coil. In this way, the magnetic field is going. At this position, there is a no magnetic flux crosses the coil. Why so? Because it is situated at rest. But it is not situated at rest at any particular time. It is always and always in the rotation. Okay, this thing is always and always in this rotation. So again, I mean continuous thing. As the coil is start rotating continuously, we can say that the flux through the coil is changing with time. Obviously, till now, till this particular position, I can give the name of A, B, C, the next position, D, and then there is no, still E, F. Okay, D, E, F. So till C particular position, we can see that there is a no rotation. So when there is no rotation, obviously there is no flux change. But at particular position D, the coil is starts rotating. After rotating the coil line by 90 degrees, the magnetic flux through the coil is maximum. As the coil is rotating continuously, we can say the flux through the coil is changing with the time. And the EMF induced in the coil and the EMF induced is equal to the rate of change of magnetic flux through the coil. So again, F and then E, A, B, C, D, E, F, G, H. I am not going to write the name after this. Okay, because this is the sequence. That's why I am doing this. So after F, what is happening? It starts rotating in the same continuously. Suppose the coil is rotating with angular velocity omega. As the value of flux is changing with respect to time, so the value of flux at any instant of time can be written as phi t equals to B A cos omega t. And please, no one don't ask me what is right. I'm writing down, because in transformer I already teach you this thing, like how you can write phi A, which is B A cos omega t. Okay, is this clear or not? Flux, magnetic field related to this, and I equals to sine omega t, t equals to mu naught sine omega t. Either you can write sine, either you can write cos. It's your choice. Okay. So phi equals to B A cos omega t. Phi total is N phi t and B A cos omega t. If the coil has total number of turns n, then the value of total flux will be written as in this way. EMF equals to minus d phi by dt, NBA d by dt of cos omega t, which is EMF NBA sin omega t. Okay, is this clear? This is your EMF, and we take our you can say this particular flux starting at 0 particular thing, we have a maximum flux 1, and at 90 degree we have a minimum flux. I mean, from this particular position you can see that flux is going to be minimum, BA, which is going to be minimum, which is 0 at theta equals to 90 degree. Now what is theta equals to 90 degree? This, the area vector is going to be perpendicular, and this particular thing is going to be, rotation is going to be, magnetic field is going to be in this way. Okay, so that is why BA cos omega t, omega t is, omega is because of this, and that is why we put cos omega t. Is this clear, everyone? Is this clear, beta? BA cos omega t. Here theta I can write omega t, because angle is changing as compared to the angular frequency. And it is not angular frequency right now here, it is angular velocity, theta upon t. Theta is angular displacement. So that is why I write this BA cos omega t. Is this clear? Because if I want to make my theta, sorry, if I want to make my this flux, this is my magnetic flux related with time, so I need to do this. Clear now, everyone? Or do you have any question, query, anything? Tell me or ask me. I am not doing anything new. Just because theta is omega by t, and you can, sorry, omega is theta by t. Omega is what? Angular velocity, which is change in angle divided by time. Clear not? D theta by dt. That is how we write now angular velocity. And that is angular velocity. So I can write theta equals to omega t. Simply I can write this then. Is this clear, everyone? Good. So this is a mathematical expression of EMF induced within the AC generator. Till now we don't get current. We that's only get EMF. So according to Faraday's law, we can write the EMF induced equals to E minus d phi total by dt. Why should I write phi total? Because writing n 2 times, that is not going to work it out. So in phi total I already have NBA cos omega t. NBA cos omega t. Okay, it is already inside it. So d by dt of NBA cos omega t minus omega NBA sin omega t. I hope and I believe everyone know this thing. So NBA omega naught, it is written, if I am not wrong, sin omega t. Now we can draw the graph of the generated EMF, and that is the graph. The negative sign is induced the Lorentz law, because an induced effect is always such as to oppose the force of its product. Simply as that. Okay. Moving ahead, direct current DC current generator. Let's look it out. What it states that. Is this clear till now or not? First of all, tell me this. Is this clear with everyone? Good. So as it is written over here, the current produced by this form of electric generator does not alter direction or amplitude. As a result, the frequency of DC always is 0. And if I am not wrong, direct current generator is nothing as such, but we have a generator, and that generator is always and always going to produce the AC. Direct current generator is something else. It is not related to this subtopic. How you can generate a direct current? Can anyone tell me, please? What is the process to generate direct current? And what is direct current? There is a process to generate direct current also. Something related to chemistry, electrolytic cell or something that cell. Anyone know or not? At least reply on this. Okay, there are two process. Electrolysis. What is the electrolysis process? Electrolysis process, we dip two rods and a salted or you can say solution, and then produce a simple current, small current, and then absorb the large you can say positive negative charge. And due to this positive negative charge is stored in anode or cathode, we have a batteries. And due to these batteries, we can form a direct current. One thing simple. Another thing is simply chemical cell. Chemical cell is another form of to create the direct cell. For example, direct current. Like chemical cell, everyone knows. Like this particular cell we installed in any particular remote. That is a chemical cell. When if any particular time your chemical cell is stored, or sorry, stored, I'm saying, destroyed, or they are not working, okay, they are done their work because they are not reusable. So try to break that particular cell. You are going to find a black color charcoal, and that is charcoal is basically coal, and that chemicals changes continuously to give you electricity, which is a direct current. Okay, so here the direct current, what particular thing is written over here, this particular AC generator or simply generator which is AC creates AC only, alternating current only. Okay, and the frequency of DC is always zero. What is the meaning of saying that? As we know, direct current is this. There is no frequencies. There is no fluctuation in this. Okay, there is no fluctuation like this. So the frequency is zero. That is written with. The current produced by this form of electric generator does not alter the direction or amplitude. Direct current generator, sometimes there are so many, but due to, whatever the process, whatever the kind of generator you use, in all the things, the frequency is not going to change. As a result, the frequency of DC is always zero. Okay, and that is enough to know about it. Moving ahead, advantages of AC over DC generator. Through transformer, AC generator may be simply stepped up, stepped down. Okay, because the step up functionality, transmission link size in AC generator is less. The loss in AC generator are lower than in DC machines. An AC generator is much smaller than a DC generator. Okay, so these are some advantages of AC over DC. And yeah, now first time, not first time, but after so many, wait. Yeah, after so many days, we are going to do this lecture on time. Is this clear now, everyone? This thing. Okay. So this one is your last two questions. In LC circuit, the inductance is this, the capacitance is this. If a voltage is this, is applied to the circuit, current in this is given as. Okay. I solve it out for you because you are not gone through LC circuit till now. The next question, the next numerical you need to do by yourself. Okay. So LC circuit, LCR circuit, RC circuit, L circuit, C circuit, R circuit, we are going to understand in next class. So what is this? First of all, an a circuit which having L and C all together, and there is a alternating voltage. This is your L, this is your C, and there is a alternating voltage. Okay. So L here is 40, C here is this, and this alternating voltage V of t is 10 sine omega t. Instead of sine omega t, okay, we write in this way sine omega t. So omega here is 314. Understand how to do this. Sometimes SME think you are that much intelligent enough, so he or she provides us a question which is related to something more. Okay, so this is your LC circuit in simple sense. Okay, so now given L is this, C is this angular frequency, because omega t comparing this Vt sine, okay, d naught sine omega t, which is Vt 10 sine 314t. So comparing this thing V naught, which is peak voltage. Okay, what is a peak voltage? So many things I need to teach you. Anyone know what is a peak voltage? Okay, I'm going to draw. Please tell me what is a peak voltage here. If it is my voltage of time related, okay, if it is my time related voltage axis, if this is my time, what is the peak voltage here? Tell me anyone. In this graph, what is the peak voltage? Okay, for your betterment, this one, or this one. Which one is the peak voltage? Tell me please. A, B or C? Okay, good. So A, why not C? C is also peak voltage. A to C. No better, not A to C. Either A or either C. A to C is not peak voltage. It is a range of total voltage. Okay. Means if it is positive 5, so that can be negative 5. Both are the peak voltages. Because it is also a peak, na? Current is a scalar quantity. Still, current is not going to change its property just because it is changing the cycle. Got it? So, it is a peak voltage in negative cycle. It is a peak voltage in positive cycle. That's how we introduce this terminology. Why I say this positive negative? Because it's not a vector thing. Okay, coming back to the topic. So angular frequency, this. Now impedance of the circuit. When we have two things all together, so impedance is going to be this, XC minus XL. And hopefully I give you XC or XL in the previous thing. Okay, as you can see, XC is 1 upon omega C, and XL is the reactance due to this inductance is omega L. Putting this is your total impedance. Impedance is total opposed in the circuit. So calculating this Z, we get this, and when we get Z, now one more thing. Here XC is greater than XL, so current lead by pi by 2. Okay, and current equation, which is also dependent on time, we get V naught upon Z sine omega t plus pi by 2, and that is how we can find. If it is XL, sorry, this is the thing. If XL is greater than XC, then what is happening? Current is going to lag behind the voltage. I is going to be then V naught by Z. Okay, then V naught by Z. Okay. I of t is going to be V naught by Z sine omega t minus pi by 2. Okay, this is the thing. Is this clear, beta? Clear now, everyone? Okay. So then I equals to V naught by Z sine omega t plus pi by 2. Wait a minute, beta. Wait a minute just. Okay. So this is the method. Current I equals to V naught by Z. Z is total impedance. Sine omega t plus pi by 2. Put everything and you can get. Sine omega t plus pi by 2 is cos omega t. And then calculating this, correct option is A. Now pick this one. Okay. What is correct option A? As you can see, 0.52. So yeah, 0.52 sine. Sine or cos? Wait. Then it is going to be B. Yes, cos 4 by t. So obviously, then correct option is going to be B. 0.5 cos omega. Okay. So you can correct here. I mean, we can correct here. B. Correct option is B. Okay. Moving ahead, AC generator consists of a that much coil, 100 centimeter in diameter. Coil rotates with this RPM. RPM is rotation per minute. In a magnetic field of this, the maximum induced EMF. Tell me, this one is easy. This one we already done. EMF is rate of change of flux. So I think you get it. So much mistakes I can find in one. Okay, try this one. I got some 2000 values, sir. Option D. Exactly, the option D is correct. As we know, the maximum EMF. What is the maximum EMF? EMF E is what is omega n a cos omega t sin omega t. What it is? Sin omega t. Okay. So that is your EMF, if I'm not wrong. In general EMF, right? This is the thing, na? Oh, let me check. Yeah, I forget formulas even in while teaching to you. Yeah, omega nba sin omega t. Omega nba. I missed the minus omega nba sin omega t. So for getting and to get maximum, this E max is minus omega nba because sin omega t is 1 at omega t equals to pi by 2. Simply. So now I have n, if I'm not wrong, or a, I can get this r, and rpm. Omega is because of this rpm, and magnetic field. I have everything. Omega is basically rpm. Okay. So n into area into b into omega. put it this thing and you can get the some D value exactly. Okay, so this is done by my side. In this particular lecture, we done eddy current, inductance, self-inductance, mutual inductance, and AC generator, and all the things. But I am saying again, all the things are very, very important. Not only for this particular lecture, not only for your JEE, not only for boards, but for understanding, and more importantly for next lecture also. Is this clear, everyone? Clear? Okay.